All right, for Lab 9A, we're going to be looking at interference and diffraction. And this is part of the lab that you'll be looking at. And read the document first, because I'm going to show you the difference here. So here we have a single green laser. And what we have here is nothing. So then when we pass it through a slit, notice if we pass it through a very narrow slit, we get a very wide centerpiece and followed by a dark spot, wider again. So what happens is the light, because it's a wave, gets spread out. Be a slightly wider slit, the width gets bigger, and then if we get wider still, it gets narrower still. So the width of the width of the light on the screen here is inversely proportional to the width of the slit. So the narrower the slit, the wider the pattern is going to be. So that's for single slit interference, single slit diffraction. All right, now if we look at, say, a double slit, what you see here is we see the wide slit, but we see little individual ones in between, and that's due to interference. So this is all related to diffraction. All right, so that's diffraction. And here. All right, next we're going to do is diffraction. Diffraction grating. In this case, instead of a single slit, which gave us one big wide pattern spread out, what this does, because this has 600 slits per millimeter, it produces a diffraction grating. It's how we can measure wavelengths. And we have a single spot at the center, but instead of a spread out light, we have a light to the right and a light to the left. And this is for the green laser. And you can see what we end up with is the distance from the center out to the white one. Right one is YL, right. If you look at the document, the distance to the left one is Y left. All right, so that's for a green laser. Now we'll compare that to a red laser. Up. All right, in this case now, we have a red laser. The wavelength is slightly longer. And you can see we have a bright red spot in the center, but the two spots on either the left or right are farther out. And it turns out the separation, the distance out, depends on the wavelength of the light. Red laser is about 630 nanometers, and a green laser is around 500 nanometers. So I've done this lab on a quantitative basis with the handout. So this explains sort of roughly what we're actually looking for, and the lab handout 9A goes through it in more detail as far as actual measurements. Okay, so that's the lab.